Who remembers anything about greatest common factor? Least common denominator?
Nope. It sounds familiar.
Crickets?
Yes, I think so. Not sure.
I'm going to draw a Venn diagram. Okay?
I know.
We're going to find all the multiples of 12
Oh, I know this.
I think I remember.
and all the multiples of 24.
I think like you turn them into like with the little like you turn like one.
No. You don't know what we're doing, so just don't try to guess. Don't try to guess.
I remember. Sure.
In the last video in the last take I tried to make, you had no idea. So right now, you still have no idea. Got it? Got it. All right. Give me all of the factor. The word factor is just another word for the word multiple. So I need all of the multiples of 12.
6.
Always start with 1. 1 times,
12.
2 times,
6.
then
3 times 4.
now, to find all of the multiples, all of the whole number multiples of number 12 or any number, you list them. And once you get to the multiple where it repeats itself, that's where you know you can stop. So say, for example, we got down to 3 times 4. 3 times 4. The next one would be 4 times 3, which is the same thing as 3 times 4, but backwards. So I know I can stop. Okay. Let's list the multiples of 24. 1 times.
24.
2 times.
12.
3 times.
8.
Okay. 4 times.
6.
And then 6 times. 6 times 4, which is a repetition of 4 times 6. So I know I can stop, right? Those are all the multiples of 12 and 24. Now, which one, the Venn diagram, what does this middle area mean? What do they have in common, right? So first, now we're looking for the common factors, right? What are my common factors?
6 and 12.
Is that it?
And then 2 and 4.
2, 4, what else?
3.
3, what else?
12.
You already said 12.
Oh yeah. I think that did.
We already said 4.
1.
1.
And that's it.
Okay. Now, those are my common factors, right? Now, bring in the word greatest. Which one would be the greatest, the biggest? This is my greatest common factor. This is how you would look for greatest common factor before algebra. Now, let's see how we apply this to algebra, the algebra version of it, okay? So factoring is a process of rewriting a polynomial as a product of 2 or more polynomials. And in this case, we're just going to write polynomials. Okay. So, for example, last week we learned how to distribute a monomial into a trinomial and binomial, right? We would end up with answers like 12x squared plus 6x. But how did it look like before? 2x times 6x plus 3. So what we're going to do is we're going to learn how to undistribute what we learned how to distribute, okay? Last 6 weeks, in the last unit, we learned how to distribute polynomials. I know. Oh, remember this?
Yeah.
Okay. We learned how to distribute a polynomial into a trinomial or a binomial, yes? So with greatest common factor, what we're doing is we're going backwards. Okay? We're factoring. Now, if a polynomial cannot be factored, then it is called prime. Okay? Now, you're never going to have a prime, not in Algebra 1, so you don't have to worry about that. Okay? All of the questions on the STAR test that ask you to factor, they're going to have a greatest common factor. So, the greatest common factor, GCF, is the greatest monomial that divides into each term of the polynomial. To find the greatest common factor, you're going to look at the coefficients. You've heard of the word coefficients. Don't act like it's a brand new word. You're going to determine the largest number that divides into each term. You also need to look at the variables. In other words, look at the numbers, look at the letters. A variable must be in all terms. That's very, very important for it to be a greatest common factor. If it's present in all terms, then the greatest common factor will be the variable with the smallest exponent. Also important. Okay, now none of this will make sense until we actually put it into practice. So just hang in there. After you have determined the greatest common factor, you can factor by dividing each term by the greatest common factor. In factored form, the greatest common factor will go in front of the parentheses. The remaining factors will be left inside of the parentheses. Now you can always check your work by distributing. You can always double check your work by multiplying it back out, which is something we're not going to do. That is a lesson that we learned with the last unit. Okay. Now, yes, it looks messy. Yes, you might not understand when I explain it, but this is basically what we're going to be doing. We get an expression, 9y cubed plus 21y squared. We find the greatest common factor, and in this case, my greatest common factor is 3y squared. So we take each one of those terms and divide it by 3y squared because that is my greatest common factor. That greatest common factor is what will end up going on the outside of the parentheses. So basically, you are undistributing a monomial, okay? Now, some of us are not very good with our multiples, okay? Some of us don't know all of the multiples. In order to find the greatest common factor, you need to know all of the numbers that you can multiply to get that number, okay? Not just any numbers, okay? Just like we did up here with this example. The greatest common factor, even though 6 is a common factor of 12 and 24, it's not the greatest number. So once again, very, very important for you to know all of the numbers that multiply to get both of those, okay? Because the greatest one of all of them is the number 12. And so for that reason, you need to know all of the multiples, and this is a way you can use your calculator to find all of the multiples. You're going to go to y equals. So if you don't have a calculator, you better have one. Let me pull up my camera. All right, so you're going to go to y equals. And in y equals, you're going to type in the number the factor you're looking for. So, for example, 24, right? You're going to type that number divided by x. You could type it in fraction form. You could put 24 over x. It doesn't matter. Okay. Now, the notes say you're going to press graph, but I forgot to include you need to go to second graph because you need to go to the table. So press second graph.
Oh, that's cool.
Okay. Let me go back to my camera. So I'm going to press second graph. And notice, the first one gives you error because obviously 0 times anything is going to give you 0. There is nothing that you can multiply by 0 to give you 24. But 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. Skip the decimal, obviously. And then 6 times 4 is a repetition of 4 times 6. So those are all of the numbers that you can multiply to get 24. Yes? Yes? No? Head nods? Okay. That way I don't have to keep going back and forth to my camera. Now, let's put this into practice. So look at number 1. You always look at the numbers and the variables. So for this very first binomial, both terms have a number. That means they have to have a number greatest common factor. Okay? What is the largest number that goes into both of these? If you don't know it, make a T-chart. Because after we did a few examples of this, my first period actually knew the greatest common factor without having to make this T-chart. What are my multiples of 42?
1 times 42.
Always start with 1.
And then 2 times...
Hold on. 1 times 42. What else?
2 times 21.
Okay.
3 times...
Yes. 3 times
14.
something. 14. Are you guessing?
No.
Are you looking at your calculator?
No.
You have 3 times 14. What else?
4 times...
Not 4. You stop guessing and look at your calculator. That's why I'm showing you how to do it in the calculator, so there's no guessing.
14.
3 times 14 is there. What else? There's one more.
6 times. Oh wait, no.
Yeah.
Oh,
6 times what? 7. All right. Now, multiples of 12. Focus.
Yeah.
2 times,
6.
3 times,
4.
and then 4 times 3 is a repetition of 3 times 4, so we're done. Now, which one is the greatest one that they have in common?
6.
It is 6. Okay? So this is 6 is my greatest common factor. Now, both terms do not have an x, so x is not going to be part of my greatest common factor here. What you do with this number here is you're going to divide each term by it. You're going to divide each term by the number 6, okay? That's the number that's going to go on the outside of the parentheses. We're going to undistribute it, okay? 42 divided by 6 is what?
7x.
7. Bring down the x. Bring down the minus sign. 12 divided by 6 is
2.
2. Close your parentheses. That is your answer.
But it gets harder than
Okay? It will a little bit. Not a whole lot, but it will a little bit. Okay? Now, the very first lesson of the last unit was distributing polynomials, where we 6 times 7x, 42x. 6 times negative 2, negative 12. All we're doing is working backwards. Okay? Number 2. Can anybody tell what the greatest common factor is just by looking at those numbers?
5x.
It's going to be 5.
Us 2.
5 is going to be the greatest number that multiplies into both of them. Okay?
But Miss, what
Now, both terms also have a what?
X.
So we're going to include that in my greatest common factor. So 5x, 5x. 5x is what goes on the outside of the parentheses. Now, 5 divided by 5 is 1. When it comes to your variables, all you have to do is subtract the exponents. Okay? So 2 minus 1, 1x. Okay? Now the other side, 30 divided by 5 is
6.
6x. The x is what happens with those. They cancel out. Which you get x to the power of 0, right? But x to the power of 0 is 1. Anything to the power of 0 is 1, and 6 times 1 is 6. So we just say that they cancel out. Okay? Number 3. Ready? Now this one, it might be a little bit more difficult with these digits, with these numbers, to figure out what the greatest common factor is. So let's put those into the calculator. 34 and 85. There's only 2 different multiples for them, for each one of them. So
2.
1 times 34, 1 times 85, and another one.
I want to say for like the 85, it's going to be something times
34 is an even number, so you know it's 2 times something. 2 times what? 17. 85. What's the other one for 85?
2.
85 has a 5 at the end, so you know 5 has to multiply by something. 17.
So the multiple is just 17.
The greatest common factor is
17.
17.
Could probably done that.
Now, do both terms have the same letter, same variable?
No.
No, so a letter or a variable will not be included in this greatest common factor. The only thing is the 17. So 34 divided by 17 is 2x. Bring down the plus sign. 85 divided by 17 is
5.
5. Why?
Nothing. Running out of blue.
Shouldn't be doing your notes in ink anyway. Questions so far?
No.
Okay. Everybody got this? Let's look at number 4. What's the greatest common factor? Hopefully you can see it just by looking.
8.
8. Now, both of these terms also have a what?
X.
X. So we're going to divide both terms by 8x. 32 divided by 8?
3. 4.
4. X squared divided by x is just x. Because 2 minus 1 is 1, right? 8x divided by 8x, you're dividing the same thing into itself. 1.
Oh yeah, 1.
1.
Where'd you get X from?
Flip it over.
I was thinking, where'd you get X from, buddy? Where did you
Since
get
you
4?
usually don't put 1 beside an X. Usually.
Now we have 3 terms. So yes, your greatest common factor must be a common factor of all 3 numbers. Okay?
It's 6.
Does anybody know just by looking at the numbers?
Oh, it's 7.
No, it is 6.
Yeah, because you can do 9 times 6.
Now,
and you get
all
4
3
times.
terms also have a what?
I knew this already. Huh?
All 3 terms also have what
X.
variable? X. Now, what is the smallest exponent out of all the x's?
2.
2. So the greatest common factor is x squared. Okay? So you're dividing each one by 6x squared.
This is a little bit. I don't even know what I said.
All right. Negative 36 divided by 6.
Negative 6x squared.
And then x what?
Squared.
4 minus 2 is 2. Bring down the minus sign. 24 divided by 6.
4. X.
4x. Bring down the plus sign. 54 divided by 6.
9.
9. And you're done.
Let's go.
Okay.
Intelligent.
Now, on the STAR test, I don't care if you do this on the assignment or not, because you'll be able to recognize your answer. On the STAR test, they might distribute out the negative because they don't want that very first term inside of the parentheses to be negative, okay? So when that does happen,
We'll move it to the back. Or something.
move it to the outside. But if you're going to take out this negative,
You have to
that
put-
changes the sign on each one on the inside. So this negative here is going to change to a positive, positive, negative. Okay? So 6x squared plus 4x minus 9. Once again, I don't care if you do that on the assignment, but both of those are considered
Does
correct
Does
answers.
that change the whole thing?
It just changes the sign.
I know, but I'm saying like, does it change the whole equation?
It doesn't.
No, because if you distribute this back out, you still get the same answer.
Ah, okay.
Yeah. All right, next one. Do all 3 have a coefficient?
Yes.
No.
No. So will there be a number in our greatest common factor?
No.
No. But all 3 do have a what?
X.
X. And the smallest exponent is
3.
3. So we're going to divide all of them by x cubed. Even if we don't divide by a digit.
So it'll just be the first one.
X cubed divided by x cubed is
X.
1. Bring down your 7. You're dividing the same thing into itself. 3 minus 3 is what?
X. 7x.
No, here. 3 minus 3 is 0. Anything to the power of 0 is 1. All right. Bring down the 7. X to the 4th divided by x cubed.
X.
Subtract. Yeah, it's just x. Subtract 4 minus 3 is 1. Bring down the minus sign. Bring down the 4. X to the 5th divided by x cubed.
X squared.
X squared. 5 minus 3 is 2.
Dang it.
You need to slow down.
I'm lost in the sauce. What sauce? There's only ranch. Shut up.
All right.
Wingstop Ranch is peak.
Hey, Susie, if you stop making additional comments, Kennedy might catch on. All right. What is the greatest common factor, or what is the largest number that you can multiply to get all 3 of these?
7.
4.
8.
Dang it.
If you do not know this, it's very, very important that you make your chart like this. Okay? Make your T-chart. If you do not know it. All right? Now, all 3 also have what variable?
X.
What is the smallest
2.
x? A 2. So everything's going to be divided by 8x squared. Okay?
It's just
Now, first divide the numbers, then subtract the exponent. 40 divided by 8, 5. X squared, or the 2 minus 2 is?
0.
So it, what?
1.
Cancels out. Bring down the plus sign. 24 divided by 8,
2, 3.
3.
X.
3 minus 2,
X.
x. You can put x to the first, it doesn't matter. 56 divided by 8,
7.
7.
Jesus.
4 minus 2,
X squared.
x squared. Questions? Kennedy, you catching on? A little? Okay. What is the greatest common factor in the next group?
9.
3.
9.
Yeah.
9.
3.
Come on.
3 is a factor of 9.
What is the greatest common factor as far as the variables?
2.
X squared.
X squared.
Will we eventually have to find the greatest common factor in an exponent?
We are doing that.
No, in an exponent.
No.
Okay.
I don't think. Okay. All right. Negative 27 divided by 9.
3.
Negative 3.
Negative 3x what?
Squared.
Bring down the minus sign. 54 divided by 9.
It's negative.
6.
Negative 6 what?
X.
X. And 9x squared divided by 9x squared?
1.
1. You're dividing the same thing into itself. Now, or just for purposes of the STAR test, because that very first inside term is a negative, we can also pull that negative out. So that very first term is going to change to? It'll change from a negative to a positive 3x squared. Minus 6x will change to?
Plus 6.
And then plus 1 changes to?
Negative 1.
Minus 1. Now, once again, don't have to do that on the assignment, but you need to know that that is a possibility. Okay? Last one. Ready? Joanne, are we good? Okay. What is the greatest common factor here?
5.
No.
No.
Okay.
It's a variable.
So if we don't know, what do?
Oh, it's prime.
C chart.
15.
It's not a prime.
15. It's 6.
15.
I don't know. Let's do it. So,
It
for
is
75,
wide.
1 times 75, what else?
Huh?
5 times.
Don't guess. Put it in the calculator.
7.
Practice putting it in the calculator for those numbers that you don't know about.
1 times
15. 3 to 25.
3 times 25. And then what'd you say?
5 times 15.
5 times 15. Now let's do the 60. 1 times 60. 2 times.
30.
3 times.
10. 20.
20.
Oh, okay, I get it.
4 times.
15.
5 times.
8.
5 times 12.
12. And then 6 times. 10. Now, which one's the greatest common factor?
50.
The 15.
I said 15.
Yes, but there was a lot of guessing, so we needed to practice doing the chart.
Probably could've
Okay?
gotten
No, I guess 15.
Now, both terms have what?
X and Y.
X and Y. What is the smallest X exponent? What is the smallest Y exponent?
3.
So put a 3 on that Y. We're dividing them all by 15xy cubed. 15xy cubed.
That's a big number.
Now, when we divide 75 divided by 15, what do you get?
5.
5. If you do the chart, you'll have the number that's left behind right there next to it.
Okay.
So, x squared divided by x is x. Y cubed, what happened with those?
They
Cancel out. So bring down the plus sign. 60 divided by 15? What was left behind? 4. X divided by x cancels out. Y cubed divided by y cubed cancels out. Questions? All right.
It doesn't seem that hard.
I think this year,